So I have a great job. I work at Johns Hopkins, and I get to work with physicians, and I help them look at the data they collect from patients and try to help them make decisions on those patients. And so what's really been fun about it for me is that I get to help them with the data collection, the data cleaning, and then the analysis on that data to help them understand subsets of their patients that might have a different diagnosis or respond differently to a treatment. And what's been powerful in my journey is that they're great clinical researchers and they're great physicians, and they're trying to ask basic questions about their patients. They get tremendous value from using tools like Atlas. They want to ask clinical questions, and I find that Atlas is just a tremendous data science application for them to use. And so what I see is the need for tools like Atlas in almost any learning health system that's trying to conduct clinical research. And so the session that we're going to start now is how do we put all these pieces together? So we've got a lot of different technologies. Some is based in R, some is based in Java, JavaScript. We have, and so we have all these different pieces of the puzzle that we have to pull together and then deploy. And so when it comes to deploying these within a health system, which I think is going to be can create enormous value, and the more value, of course, that we create, I think you'll find a lot more people that raises our pool of people to become contributors as well. Is really trying to be able, how do we deploy these tools with an enterprise IT perspective in mind? And so how do we then put these tools into, how do we support them? How do we make it easier to install these tools? How do we make, I really want to do more than just the data model. We really want to deploy the applications as well, because this is where all of our validated statistical models come in, and our methods and our complex cohort definitions and phenotyping really we can build off of. So we're on a quest to see how we can make the whole stack of OHDSI something that we can make more enterprise IT friendly. So I'm really honored to have a great group here today for our closing session around how do we put the pieces together, and how can we learn how to become more nimble, and how do we ensure that we are delivering secure technology without vulnerabilities, and how can we make it flexible so that we always can be able to handle the next new network study that Mark designs for us. And so with that, I've got 4 great panelists from, we have Lee Evans, who is a Titan Award winner and is the founder of LTS Computing, and he helps organizations to migrate their data to the OMOP data model and help them roll out observational research tools. And he's been really the mover for our Broadsea initiative, which is trying to containerize our technology and make it easier to deploy and support within enterprise IT environments. And we're also joined by Corey Stevenson from Microsoft, from Vivian Neely from Google Cloud, and James Wigan from the Amazon AWS. And so it's really exciting to see these environments where we can now deploy our technology stack and try to simplify that whole process. Lee, do you want to introduce yourself and talk about Broadsea?
Sure. Can you hear me okay?
Yep.
Great. Let me just share my screen. I have one slide. Let me just go to that. Okay, so there's a little bit of a busy slide because there's a couple of different topics I wanted to talk about. So first of all, just to sort of reintroduce OHDSI Broadsea, because it's been in the background for several years, hasn't really had much attention, and I think we want to bring it back and bring out a newer version of it and get things up and running better on a better basis than they have been. So Broadsea is really just, it's kind of like an OHDSI project around how do we package up the tools. So Atlas, Web API, and then RStudio and Hades. So in the top left corner of this slide, I just wanted to show you, these are the main sort of containers. Docker containers are basically just images of the software and all the dependencies associated with them. And we've had 6,100 downloads of the web tools of Atlas and 8,700 downloads of the methods library, which the methods library probably should now be renamed to Hades, just to match that. And these containers, Docker containers, can be installed anywhere that you have a Docker engine running. They can be installed in Kubernetes as well, and they're available, freely at the Docker Hub. So if you go to Docker Hub and just type in OHDSI and Broadsea, you will see them out there. Now they haven't really been that well maintained over the years, so actually the latest news from me is that there's a new version of the methods library out there, which is up to date with the latest Hades. So I think that's going to be a big advantage going forward. We want to keep that up to date as well. So I would like to indulge myself a little bit and just give a quick demo of that, because Martijn did say that it's kind of hard to install Hades in a couple of minutes. But if you can see my screen, let me just show you, just to prove. Nothing running here, right? So what I just wanted to show here is this is how you could take an existing Broadsea container. So in this case, it's a Broadsea methods library, and it's now labeled as 130, which matches the Hades package version. And you can get it up and running. So there's a little bit of a cheat because I've already downloaded this image from Docker Hub, so we're not waiting for that. But now I have started it, and we'll just load into here, and we'll do RStudio. And now we have RStudio running, and we have all the packages from Hades. So you can see Achilles and database connectors there. We've also got the JDBC drivers. So this is a quick way to get up and running with Hades. All right, let me go back to my slide. So I guess it'll be important just to say a little bit about how we build OHDSI software. This is an open source conference. So right now, there's a couple of different ways that we do it, and there's definitely a way that I prefer, and I think the way that we should go in the future. And this has sort of been championed, by Martijn and Mark, and moving over to GitHub Actions. So right now we have a sort of combination for the packages. We have GitHub Actions and CRAN as a repository. Over on the right-hand side here, we have Jenkins, which is a kind of an older approach to building software. And that's used on, I guess, the Java side of the house, Atlas Web API, all those pieces. And we have a repository, repo.ohdsi.org. So when we build the software, it goes out up into that repository, so you can bring it down and install it locally. And then the third actual sort of pipeline and workflow to build the software is part of Docker Hub itself. So when you push a container, if you connect Docker Hub up to GitHub, then when you push to GitHub, it will build that image for you. And we've had some challenges around that because of the size of the source that's being downloaded. So I would really prefer to move to GitHub Actions, and that's something I'm looking to do this year. So last thing I wanted to say, so we have options for containerization. You can install the software directly if you want to, but also there's some really good options for installing all the OHDSI tools in the clouds. And obviously we're going to hear from James and Vivian and Corey about that. I know that was a very quick demo, a quick overview. I just wanted to take 5 minutes though. So does anyone have any questions?
And do you know of any? So we use Broadsea at Johns Hopkins off of the AKS cluster, and we are able to run several instances of it for each of our clinical registries. Do you know of other sites that are using it at scale?
I'm not really too aware of who's using all the Broadsea containers, but I know there's some universities in Germany that have used it. I've used it, installed it, at least at one major pharmaceutical company. And with a couple of startups as well. So it really varies. I think you can use it on your local desktop if you want, a laptop, or you can use it up, enterprise level.
And yeah, we're going to go through a quick introduction with each of the speakers, and we'll have a time for general discussion. So please prepare your questions and ask them in our chat session. And then when we're done through introducing all of the panelists, we'll get into a general Q&A. So our next presenter is James Wiggins, who is another Titan Award winner and as a leader in the global public sector healthcare solutions architecture at Amazon Web Services. And AWS is really the first cloud provider that was able to, that will put together OHDSI for the longest period of time. And so, James, it's great to have you here and to hear about some of the experiences you've seen with OHDSI on AWS.
Yeah, great. Thanks for having me. Can everybody see and hear me and see my slide as well? Okay, cool. Yeah, great. Yeah, thanks for having me. Like Paul said, I work at AWS and I lead a team of technical folks who support public sector healthcare customers worldwide. So government, nonprofit, academic, yeah, have had the great pleasure of working in the OHDSI community for a little while. And so I guess I'll just give kind of an overview of where we're at with OHDSI and AWS. So some of you may know that there are sort of two ways you can easily deploy OHDSI on AWS. One of the projects is called OHDSI on AWS. And that really is geared toward enterprises, multi-user OHDSI environments, kind of larger scale implementations of OHDSI. And then we also have the really popular OHDSI in a Box, which was not started by me. It was actually started out of IQVIA, Sean Iannuzzi and Louis Van Zandt, and has just kind of been, I've added some to it as well. So that really has been a collaborative project there. But the idea there is you get basically kind of a personal learning and training environment. It's kind of more geared toward single user use, but either way, you can use this automation to deploy kind of full featured OHDSI environments in like an hour or less on AWS, and it's pretty fully automated. You know, you click the buttons and then you get an OHDSI environment out the other end that you can just begin using, even with sample data. So we'll talk about that a little bit here as well. So I'll focus in on OHDSI on AWS because that is sort of the more robust implementation that could be used by institutions and maybe to really support like kind of complex studies and things like that. So OHDSI on AWS has been available, Paul, like you pointed out, since 2018. So it is a fully automated deployment on AWS of OHDSI, and we'll talk about what that means. What is quote unquote OHDSI? But OHDSI and OMOP, the OMOP Common Data Model, and also sample data, or you can provide your own data sets, right? Like if you have an OMOP data set, you can point to that. It will also automatically deploy that into the environment and do some other fun things like run Achilles and stuff like that. Over the years, I just looked prior to this presentation. It looks like, you know, we get about 6 unique users in the GitHub repo per day. I'll post a link to that. You can find it under the OHDSI GitHub site. It's just OHDSI on AWS, or if you just Google OHDSI on AWS, you'll find it. I also looked at, there's been over 10,000 customer launches over the past 4 or 5 years or so. That's pretty incredible. I doubt that all of those environments are still running. I don't know how long they all lived. But I do know from working with customers that it has been deployed by organizations kind of all over the world. And even in China, actually, it's available in our AWS China region, which is air-gapped from the rest of our public global regions. And has some other constraints being behind sort of the Great Firewall, but you can actually deploy it in China. It has been deployed in China as well. Eden also kind of contributed to a lot of EMEA use of this. I've seen several of their SMEs that have used the OHDSI on AWS automation to deploy for their Eden partners. And it's been used in a lot of OHDSI symposiums. I don't know if it's been used in everyone since 2018, but it's been used in many of them, as well as OHDSI in a Box to support some of the tutorials. It's a great pleasure to work with a lot of folks on this call to make that happen. So one of the things that we were talking about prior to this presentation is, you know, sort of what is OHDSI, right? And we say, oh, it deploys OHDSI and OMOP. What is OHDSI? OHDSI, I think, as why we're all here, it's sort of a collection of at least probably dozens and maybe even over 100 different open source projects that you kind of can combine together. And each one of these has their own sort of unique life cycle. So this is just a list of some of the projects and version numbers that are the default for OHDSI on AWS. But when you deploy OHDSI on AWS, you can specify the version numbers for these projects that you want to be combined together. And the version numbers that are here, the defaults are just ones that I've tested that sort of work together, and I update it periodically as the projects move forward. But I think that's a good, maybe a question that we could discuss is like, well, what is OHDSI? You know, what does it mean to deploy quote unquote OHDSI? And these are just a couple of high level. You can find this information in the GitHub repository as well. Kind of the high level architecture of like, well, how does it get deployed on AWS? Sort of where do the pieces go and some of the services that are used. And then there's some more detailed documentation as well if you have curiosity about like, well, how is it structured from a network perspective and sort of the infrastructure security that's applied. A lot of that documentation is available in the GitHub repo. So I will, I'll share real briefly. I know I'm probably getting close on time here, but I'll share really briefly. This is the GitHub repository where you can the process. Excuse me. The process here is really just choosing the AWS global region where you want to deploy your OHDSI environment, clicking the Launch Stack button, and that will engage the automation service called CloudFormation in AWS. And when it runs, the output is these kind of links here. So after about an hour, you'll get these links. I'll close this and just reopen them. So you get a link to Atlas, so you can log in and start to use Atlas with your sample data, or if you chose to bring your own data, it's kind of fully functional Atlas environment. You have RStudio, and it has a lot of the popular libraries installed, like Hades, for instance, right? You can just do that. It comes with a file that tells you the connection strings for your databases and the schema names for all the schemas that you loaded. You can load as many OMOP sources as you want. And the same thing, you basically get the same thing in Jupyter Lab. This is something that John Duke asked for a class that he was using this to run out of Georgia Tech is basically you can run R or Python code in the Jupyter Notebook environment as well. So yeah, thanks for giving me the opportunity to share about that.
Yes, this is great. Thank you. Thank you, James. Our next panelist is Vivian Neely from Google Cloud Complete, where serves as an interoperability lead.
Thank you. Yeah, hello, everyone. As Paul said, I'm Vivian Neely. I am the interoperability lead at Google. So I actually cover North America, but I generally come from an analytics background. So the folks on the panel are much more application focused than I am. I do a lot of our kind of standards-based work at Google. And I'll talk a little bit about some of the ways that we are supporting OHDSI on Google Cloud. I think it was a good point. It was a good call to really kind of what is OHDSI, since there's so many different tool suites that we're talking about during today. But really, the way that we are currently supporting OHDSI is a few-fold. The architecture you're looking at right now is really stood up by Odysseus. They manage a lot of our VMs and kind of managed servers that can just spin up various OHDSI tools on Google. And so as you can see here, the base support is actually on what's called BigQuery. BigQuery is our data warehousing product. It's basically a very large scalable SQL product. And one of the amazing things about BigQuery is it helps users scale to basically petabyte level size. And so I'll talk a little bit about what that means when we talk about the tool suite. But essentially, we have built a connector. It's an ODBC, JDBC connector between some of the tools in OHDSI, specifically Atlas and Achilles, to BigQuery and support of OMOP on BigQuery. We do that all surrounding, a lot of kind of the identity and single sign-on and security within the Google Cloud Platform environment. I think that's something we'll talk a lot about, is how clouds can kind of help secure this entire environment for the end user. Specifically, I like to call out one of our customers, and actually, I meant to say, for Broadsea, we actually do have University of Colorado. If anyone's on the phone from there, they are using Broadsea on Google Cloud Platform. But I actually love talking about the work that Stanford has done on Google Cloud. They actually recently, I say recently, it was 2020, published a paper that essentially went and did an analysis of what's the value of having performance on a managed database like BigQuery versus an on-premise database. And we actually came out and it was 10 to 100 times faster to run it on a managed cloud database. Specifically, we were testing BigQuery here. And I think throughout the conversation, we'll talk a lot about how is managed databases helping some of the users to be able to do things faster, easier, and better kind of from a deployment standpoint, and being able to really be able to scale at an enterprise level. The Google Cloud specifically has a few different tools that I like to call out that we have. My favorite is actually we have a public data set program that has a bunch of different options and public data sets that can all be accessed through BigQuery. You actually don't necessarily even need a Google login to do this. You can go look at what is available today. One of the data sets we have is actually the SynPuff data set on OMOP. And so we have 2 million patient lives on top of our public data set. That's actually what, when you kind of auto launch Atlas from our marketplace, that is actually what it's going to be defaulting to. And so I think one of the things that we'll talk a little bit about, but the value of having a kind of out of the box public data set to use means that you're not necessarily defining DDLs. You're not necessarily having to upload data yourself. We kind of give a starting point for OMOP. And I included here a lot of the statistics, over the period of time that we've had this public data set, actually 115 terabytes have been queried of the data set. And so I think that's a pretty phenomenal kind of nod to how useful this is to the community, hopefully, or hopefully folks are using it. As you can see, I guess folks are using it as it's something that you can do a lot of testing environments and kind of running things off of a public data set without necessarily having to manage things yourself. We do have a marketplace image. It's just a VM that has Atlas on it. It's kind of a click to deploy option that is also managed by OHDSI. We'll talk a lot about Kubernetes today. We are kind of transitioning. I joked with my panelist earlier. I was like, oh, we're still in the legacy VM days. And so I was talking with Greg and folks. We'll probably be looking at transitioning this to Kubernetes in the future. But overall, I think we try and kind of aim for providing out-of-the-box functionalities for Odyssey users that can kind of be easily, very quickly deployed. And so whether that's kind of a data set to use or a click-to-deploy marketplace option, that's a couple of the ways that Google Cloud is like helping our users, whether they're familiar with the Odyssey community or not, be able to get started.
That's great. Thank you. Excellent. And our last panelist is Corey Stevenson, who is the Digital Application Innovation Specialist for Health and Life Sciences at Microsoft.
Hi, everyone. Can I present? Let's see if I can. I should be able to. I didn't ever see the little pop-up that says, you're promoted to presenter.
You are.
So, well, thank you for having me, Paul. This has been a really fun day. It's also been fun to get to know my AWS and Google counterparts and see just the different ways we have each taken an approach to Odyssey in the cloud. And so to that, I'm going to talk a little bit about where we are in the journey of Odyssey on Azure. I will say up front, we're probably the youngest of the three as far as pulling all the pieces together. I know there's multiple instances running, but as far as going to a unified model of deployment, we're the youngest, I'll say that. But before that, I do want to hit on one topic that was actually the motivator for us to get involved in this world of deployment, scaling, things like that. And we ended up with two motivators. And I just want to say that, like, I saw these problems emerging as I talked to customers. While I am an app specialist now, I have a deep background as a cloud data architect. And I brought some of that, I'll talk about this in a minute. I brought some of that Hadoop experience to the design of some of what we're doing today. And I'll talk about in a minute why that's important. But this third one, which I think all three of us have hit on, is the ability to deploy and operate Odyssey on a cloud, or just in general, is very painful. In siloed IT departments, in the VM world, it's like, oh, well, what do you need, researcher? I don't know. You know, I need some stuff to build some stuff, you know. And so they go and say, well, you need a database. So you submit a ticket for that. And then you need how many VMs for that kind of stuff. So it's a very common problem. But so I created this hypothesis about what would it do if we actually created Odyssey on Azure. And this came out of talking with some researchers at various organizations. And one of them one day I was talking to, and it wasn't about Odyssey, it was just about research in general. And they said, I noticed they were very passionate about getting their data into Azure very quickly. And it was very abnormal. And I said, what is driving this? And they said, funding. Funding, we can't get grants because we're limited to the amount of compute on-prem. And our organization is driven not just by patients and care, but also by these funding, these outside grants, benefactor investments, things like that. And I was like, oh, so we're not just, by not having Odyssey on Azure deployment scripts or cloud deployment scripts, we're not just blocking research, we're blocking organizations from being able to grow and have funding in these very tight times. So that's really what drove some of this. And then I'll just show an architecture on kind of where this is, because this also drove me to think about the complexities. And this is where my Hadoop experience came in. So if you're familiar with Hadoop, we have a thing called the zoo, which is really similar to all the modules inside of Odyssey. How, what do I want to plug in? Where do I want to plug in? How do I stay up to date with each edition or each version? So we've taken a very containerized approach, and a lot of our focus has been on deployment. So how do we maintain not just deployment the first time, but deployment through dev, test, prod life cycles. And we've started with Terraform as a script. We've built out DevOps pipelines. Currently it's in ADO. We made the decision this week that we should probably flip everything over to GitHub Actions. And so we're in the process of doing that right now. But there is, a repo out there. And when it builds your Terraform, builds your pipelines, and it deploys Odyssey on Azure with a flag if you want to do Cynthia data in your database. So you can create a sandbox right from the scripts. That's all I really have in the short amount of time. Looking forward to the rest of the questions and the rest of the conversation.
That's great. Thank you, Corey. Thank you so much. We're happy to have you in the Odyssey community. So please ask your questions in the meeting chat. I'm taking my prerogative to ask the first question because I've got the microphone. And so one thing that James showed was he showed all the different packages and the versions of those packages that they're using for AWS. And so each of those packages have their own release cycle. There's no synchronization about when we release something as an organization about what is. And so I'm wondering, how does this environment keep us so that we can stay on the latest and greatest version for our package? And what might be some of the benefits if we can kind of get to a similar, release timing so we can do maybe better testing. But I thought we'd start with James on how we could do, is there a way for us to do faster release management, so we can always stay on the latest and greatest versions, which we need for running our network studies.
I guess my thought around that would be, and I don't know what's more important to the community, being on the latest and greatest version, or having a consistency throughout the network that enables compatibility, reproducibility. I don't know. I think that there are probably some trade-offs there. Certainly with these technologies for deploying kind of the DevOps, right, the software and the infrastructure together. You can sort of easily sort of swap out infrastructure components with the software packages installed. So like with OHDSI and AWS or the other automation, for instance, you could redeploy your environment with the latest version numbers, and that is something you could do in a matter of hours. But I think what that kind of hints at is, are there approved, tested, agreed upon combinations such that you can say, hey, I'm on OHDSI 1.0, and that means all these packages at all these version numbers, and we've tested them from a performance and from a results perspective, and we know that they produce, kind of accuracy, and it's sort of a best practice, and then the whole community could move to sort of OHDSI 1.1, and then it would make it kind of very easy, because I think when you talk to a customer today and you're like, what version of OHDSI are you on? Like, that's like a super complicated question, because you've got to answer it in terms of all of these packages, and then also, and it's not just those packages, right? It's also, well, what Python version are you on? What R version are you on? The packages in R, the non-OHDSI packages, the non-OHDSI Python libraries, and your operating system, and Java, and all that. It's like, there's a lot. So I think to consolidate that into this defines OHDSI 1.0 could be something that's beneficial.
Lee, Corey, or Vivian, do you have anything else you wanted to add? Because I would agree. I think we probably don't do enough end-to-end testing on all the different packages, how they could go together, and I think we could do a lot. But we could probably improve the stability of the system if we had more synchronization.
Yeah, I think there's something to be said about deployment tools like Terraform that could help us kind of package all these things together and have a single consistent way to be deploying versions, and a single way people are updating that. And so I think I also find it would be helpful for us to start leveraging and packaging some of these together, so that when we are doing those testings and deployments, people aren't necessarily upgrading one and not the other. It's kind of a full, a full rework of the environment.
Yeah, I would just add, go ahead.
Go ahead, Lee. No, go ahead.
I was just going to say that I think containerization can play a part in this. So we can make sure we're rebuilding, say, Broadsea containers when we see the upstream our official images that we use when they're updated, when there's OS updates, and then we can also use containers for versioning. So if you need to go back to a previous release of OHDSI or Hades and Web API, that should still be out there in Docker Hub somewhere, and easily accessible to, say, go back and rerun the study.
Yeah, actually, I was going to say something similar to Lee on that, and just emphasize his last point about versioning in Docker Hub, and just the best practices we've talked about throughout the day, whether it's in GitHub packages, whether it's in Docker containers, like those versions are going to be really important as we go forward as a community, so that we can pull different things down, different code repos down. And that's why I made the Hadoop reference, because I think this is a great opportunity for us to learn from other areas that have gone before us. I like to find places that have gone before me and try to reuse them and take learnings from them. And the zoo animals of the Hadoop ecosystem is one I find a good correlation here. But that also leads into a conversation about code security, which I think we might get into a little bit later. So I don't want to jump the gun on that one.
Yeah, actually, I can segue into that right now. So I feel like when we asked to deploy stand-up Atlas servers and Web API in our health system, we go through an enterprise IT security review. And that is really, what do they want to know? Well, they want to make sure, are we introducing any vulnerabilities into our environment? That really, and so the question I have for our panelists is really, you know, how can you help partner with us to ensure that we're keeping our patient health data secure and not introducing any vulnerabilities into the networks that we're running the software on? Because you have a lot more security people than we do.
Yeah, I mean, I'll start with that one because Microsoft's been very bold to make announcements about security with some of the worldwide events going on. And, you know, I believe, I know AWS, Vivian, you can talk more about Google, but we each have a set of monitoring tools that are typically PaaS-based. I even had it on my architecture as part of our deployments as we move into the enterprise level to help be reactive. Now that you've already put it out, and what we encourage customers to do is actually use those tools in their sandbox and tests. Now, why? I'm not trying to make like a sales pitch on that, because what I am saying is a lot of the work we do as clouds behind the scenes together. There's lots of studies where, you know, Microsoft and Google, I forget which one, which attack it was over a holiday, like came together and really worked on some stuff because we saw a big value in that. And we do work together behind the scenes more than people know around security things. And we bring that out to our customers in the form of these PaaS tools and these PaaS algorithms. And then the other area that I think are best practices that we can start helping even more is code up front. You know, it's one thing to commit a PR, but how do we know that the assets or packages that have been added are actually up to date in that code? And that's something our team is actively exploring. How do we bring those tools to, and what are the best tools to bring to like our GitHub repos to scan things as they come in, or container scanning as we help deploy?
And Lee, did you want to talk about some of the things we're currently doing with Broadsea for security?
I wanted just to call out, you know, from Microsoft and GitHub, the Dependabot bot that runs on a regular basis and just checks in GitHub to see you've got packages that are up to date. That's been really helpful. So that's a very nice asset to have. I think we could do more around scanning. So I'd like to implement scanning of containers that we build for CVEs, for vulnerabilities. I think also potentially we could look at doing Docker content trust. So being able to sign the containers that we build, container images, and then it's up to the site that wants to install it, whether they want to turn on that content trust and only install things that are signed. So there's definitely some improvements we could make on the container side.
Just from a like an overall cloud perspective, the base level of security that is given and provided basically by default is oftentimes stronger than what an individual might get on their own instance. So for example, we encrypt by default. All data is encrypted anytime it's stored in GCP. And so, and that's true for most clouds. The ability to encrypt data at rest, in transit, manage your own keys, things like that, from a data layer, add a very, very simple level of security that is kind of more complicated for a user to do on their own. And so I think there's also just a lot of kind of like innate cloud abilities that are added to the instances when using one of the three versus what someone might have. So I think innate security is also helpful.
Yeah, I think that's a good point, Vivian, is that, you know, that when research customers I work with, when they want to start a research study, there are kind of a lot of data management hoops that they need to jump through to get started, right? IRB approval, and they have regulatory requirements, maybe from their national government. And so I know that OHDSI Network Studies, I mean, directly addresses some of those challenges by letting the data stay in their locations and only aggregate results, which is, you know, completely brilliant and game-changing, and enabled things like the COVID study-a-thon. I think in a similar kind of way, you can, and I've seen customers, you know, certainly leverage the cloud to kind of, if they need to meet a local regulatory requirement like HIPAA or HITRUST or GDPR or FISMA or FedRAMP or all of these things that you need to do to handle government data or PHI or whatever. A lot of those baseline requirements are met by just deploying your platform on a cloud. Like for instance, if you look at the like the OHDSI and AWS environment, I'm sure this is similar with the Google and Azure architectures. Those services are HIPAA eligible. They meet HITRUST. They, you know, and actually like the N3C project was built on AWS for the National COVID Collaborative. I forget the 3 C's. Somebody on here knows, I'm sure. In part to meet the FedRAMP high requirement that was required, right? Because it makes it dramatically easier to meet those compliance requirements than trying to build all that out and get an ATO in your own organization. So.
Well, that's great. So, and Adam, do you want to ask your question?
Sure. It's good to, thanks everybody for joining. I guess one question is, what are sort of your future plans for cloud deployment, and how can the open source community and the developers support you know, better cloud integration?
I'll start because I might be taking Odysseus's thunder here, but we're actually opening up a sandbox environment on GCP where we funded the ability for someone to go in, you know, working groups to go in and test out environments on GCP without necessarily paying for it, because there's a lot of value in enabling our developers. And most of the time, as we said, budgets are often based on grants and things like that. And so there's a lot of work we are trying to do to help make this as easy as possible. I kind of like the idea and would welcome the discussion of how can we, I would almost put this back, how could we help you as a community? What are the things that you would want to see from us in support that we either have or don't have to better kind of enable this partnership?
I'll share, Adam, I'll share some thoughts on, you know, I think a lot of what we get engagement from customers on recently has been actually around the data itself and kind of the transformation. So we do have teams now in AWS. I know we've got tons of great partners, and I definitely want to give a shout out to Odysseus and others that can do this as well. But we do have capabilities to help customers map and transform into OMOP also. I think that there's also a lot of work being done across the community to kind of automate and speed up that transition to get more data in OMOP such that more people can participate. The other thing I would really like to do kind of as a next step, I mean, I would say, I think it's relatively easy to deploy an OHDSI environment if you have OMOP data on AWS, but that linkage back to the core projects and kind of release life cycles and standardization. I mean, I think it would be great to have, you know, kind of going back to that OHDSI 1.0 idea, to have OHDSI on AWS 1.0, you know, like, so instead of picking all these drop downs for the different projects, I just have a few links where it's like, well, do you want to deploy OHDSI 1.0, 1.1, 1.2, you know, and whatever type of study or people you're collaborating with, you just choose whatever version everybody's on and then deploy it. But I think that may be a step forward, but I'd love to hear from the community too. If folks have ideas or they want to participate, all the code is on GitHub. I'd be happy to chat about, you know, how to advance the project to make it more useful.
Yeah, I'll chime in with the last two. I think we're working on is we've received a lot of feedback. How can you simplify an AKS deployment? You know, and this is more from the operations teams that have said, hey, for containers, we've standardized on this methodology. We already have the network security set up. So how can you help us in that manner? And what's been fascinating in that is they're not always asking for build out the template. They're asking for what are the best practices that the Odyssey community has come up with, like a deployment side of this. And, you know, that's something I'll ask from the community is, you know, as we grow, I would almost see like we need a audit or Odysseus-led deployment team, you know, that starts looking at these, building, like James said, you know, here would be a best practice of default if you're just getting started. Just a little bit more than what I would call the Odyssey in a box. Now that you're ready to move to cloud kind of thing. The other future that we're keeping a close eye on is new data types. You know, we don't really live in, or we definitely don't live in the world of columns and rows anymore. We've hit on one about, you know, fire to OMOP, OMOP to fire. That's just one of many, but what do we do with imaging data, pathology data, lab results that come in the form of a fax, you know, because that organization has outsourced it. And we need to do NLP on clinical notes. Like, these are all pieces that we kind of talk about and talk around sometimes, like NLP into OMOP. It's like, oh, well, that could be the ETL bucket. Somebody else could do that, you know, kind of thing. So those are the areas we're keeping an eye on. And when I say keeping an eye on, that means we're finding customers, partners, academic centers that have the staff to experiment with us. One thing I know from being in the cloud, I'm sure Vivian and James can say the same thing, is we can only do so much in our little test sample environments, you know, sample data environments. We need people out there going, yeah, this user interface is terrible. This experience is terrible, or this is great, but, you know, kind of thing. So those are our kind of roadmap and investments.
And Lee, I know you touched on, when you talk a little bit more some of your wish list for Broadsea's future.
Yeah, so I guess indirectly, you know, there's a potential there for the cloud systems to use containers that are produced by Odyssey. So there's consistency there, especially if we can, you know, do a better job of versioning them. And I think we are going to get better at that. I'd also like to containerize more of the Odyssey toolset. So CDM inspection report. Claire had a great presentation this morning on data quality dashboard. And I was just thinking as she was going through that, yeah, I can add Shiny, I can add data quality dashboard to the Hades container that we have. And so that will be a lot easier to get up and running. There's potentially some things around the ETL tools as well that we could containerize. But I think just in general, if folks in Odyssey, if you can keep your release branches up to date, and we can just go off those release branches, that would be great.
Good words. All right, so what's exciting to me, so right, so we have one of the things that you really can help us with is one is I liked, Lee, that you challenged Martins for his 10-minute rule, that you can get it up and running in under 10 minutes. So that's one key, is the easy button to launch Odyssey tools and then help support with the DevOps downstream for release changes in the versioning. We talked about ensuring and helping us ensure security around the data and the tools and supporting them in a secure environment. And, you know, the last question I think just plays to your strengths, and that is the fact that, you know, we also need platforms that are able to scale. You know, is that you know, we have over 1 billion objects in our measurements table. We need to be able to then scale these things to be able to handle the resources around them. And so this is the other challenge, is how do we help support the wide differences in the different environments now running these same types of tools?
Yeah, I'll maybe share. I saw Greg Klebanov mentioned in the chat. I'll give a shout out to Greg, and Adam, I don't know, maybe you were involved in this. I know Odysseus worked on it, but there was a pharma customer in the US that Odysseus partnered with to deploy an OMOP environment on AWS that that reasonably exceeded the kind of the local data size of what would be reasonable to store in a Redshift cluster. So they used this is the first time that I know of that somebody's used something called Redshift Spectrum, which allows it to read objects in S3 so that you can have, multi-petabyte or even theoretically exabyte data sets that are indexed on AWS and kind of queryable. And so I know I guess that's an example of scale that I think is a lot more approachable on a cloud provider than, it's very difficult to do that on premise. It's a big storage array contract, and I mean, that's a lot of months of bringing in hardware and setting it up and things like that. So a really cool project that Odysseus did.
I think there's something to be said about the fact if you run out of storage on premise, you run out of storage. There's not a lot you can do about that versus in cloud, theoretically there's kind of an unlimited amount of servers and, storage that you can access at any time. And what a lot of cloud providers are moving towards is the managed service model, which does auto scaling most of the time. So for example, for a Kubernetes cluster, you actually can run it on a managed Kubernetes product. I'm imagining, I think everyone has one. And it will handle the load scaling for you. And same with databases, you're not necessarily having to think about what servers you need to be able to support a managed database, because it will do that for you and without having to think about it. And I think that's something to be said when we talk about scale. One of the hardest things about scale is having to think about it and plan for it and know what you need ahead of time. And a lot of the cloud, all of us are kind of moving towards making that easier and easier for the customer. And so I would also kind of highlight managed services make this conversation a lot easier as well.
Yeah, I'll add one area that we're exploring, and it'll actually benefit all three clouds if we get this figured out right, is new databases. And what I mean by that is we have BigQuery, we have Redshift, we have what's now called Azure Synapse, which are these, parallel data warehouses, parallel data processing. I've known Databricks for years. Like when I was in the data world, I know their architects over there. And we're looking at how do we take things like data lakes and parallel processing and Spark and actually turn that and then use the SQL that comes out of, the Odyssey tools so that we can actually start changing the processing behind these things without making it difficult for customers to use. Like Vivian was talking about those, those scale items, those, what we manage versus what you manage kind of things. Databricks has a great auto scale feature. Actually, most of our products, and I'm familiar with BigQuery, so that's the one I'm going to talk about. I know it has an auto scale feature as well, as do our AKS and other app services. But scale up is great. I really like that we're starting to invest more in scale down. How do I bring the compute back down? Because researchers do their work from 8 to 5, or that query ran for 24 hours, but it's not going to run again for another, 3 weeks. Let's bring it back down to 1 core versus, 2,000 cores. So those are some of the scale things I really like, and some of the compute problems I'm looking forward to solve. The last thing I'll say about that is I feel like as we move to new data types and as we keep these billion-row tables, we're actually on the edge of on-demand HPC. We're just on that edge. And, how does someone take a cohort and simply move it into an HPC style cluster to run this code versus just traditional databases and traditional containers, or whatever method you prefer. So I think we're right on that edge, and I'm looking forward to see how we as cloud providers, but also as a community, solve some of those.
Excellent. Well, thank you. I guess so. I did have one last question, and this one is, so it's really been great to have you here today, and it's just great. I really appreciate all of the contributions you're making, and so I'm interested because you get to see a lot of other communities, and so I'm interested in how we can learn from other open source communities for how we bring people together, volunteers to build products, and so I wonder if you can share, where we can help, we can learn from the partners that you've got as well in other areas. That's a harder question, I guess.
Well, I do want to address. I do want to address one Kristen's comment in the chat, and I know it's kind of funny, but one of the things I've personally been testing behind the scenes is Microsoft's scalability of Postgre. Because yes, we are Microsoft. We have SQL Server. We've had it, since way before, since the 90s. But there's this whole nother community of databases out there, MariaDB, MySQL, Postgre. And scaling those two can be difficult based on how they're set up. And how can we make those easier? I will say Postgre is actually our first focus after getting our personal SQL environment set up. The Databricks piece, I stay in contact with Databricks and I push them on it, but they're doing most of that work. So that's where we stand on it, and I think it is something good to start building out. However, I'm going to put a big asterisk on that. There are a lot of supported CDMs in our OMOP GitHub, and how do we move forward as a community with focusing on, like, let's just say Redshift, BigQuery, Synapse, and Postgre. Just choose a smaller subset to actually make ourselves be able to keep them up to date. I think there's 8 out there right now, and I don't remember how many of them are actually up to date with both 5.3, 5.4, and 6.
Paul, I think that there's, and there's a lot, we talked about a lot today. I think there's a lot that can be done. There's a lot of headroom for growth in Odyssey, but you asked about other communities. I do get the opportunity to work with a lot of medical research customers globally. There is no other community I know of like Odyssey. This is an amazing community. I think you guys are way out in front. That doesn't mean there's not room to improve, but I think there's probably some room for just appreciating what's being done here as well.
Well, great. Well, thank you for the great panel discussion. Really fascinating to see how it is maturing rapidly, and it's really exciting to see how we can now bring it into health systems with relatively with less technical support than is typically needed. That's really going to be a key for its wider deployment, and for more health systems to be able to get value out of the Odyssey tech stack. So with that, Adam and I want to thank everyone for coming today. It's been really a fascinating day. I really enjoyed the live demos and all of the maintainers that came and presented their projects. I hope you want to join us as a new contributor for the Odyssey community. And with that, we'll close the session. Adam, thank you so much, and everyone have a great day.